Hello everyone, my name is John Cowart. I'm an instructor here at Lincoln Tech. I'm going to show you a little bit today about BTU calculations. This is basically to see how many BTUs of heat we need to do if we're going to warm something up or cool something down. So right here, to start off, let's look at this BTU graph. So we've got sections. We've got these slanted sections here, here, and we've got the flat sections here and here. The slanted sections are sensible heat. So we have sensible heat here, here, and here. What is sensible heat? Sensible heat is heat we can feel, a measurable amount of heat. Right here we have latent heat. What is latent heat? Latent heat is a hidden heat. Latent heat causes a change of state and not a change in temperature, whereas sensible heat causes a change in temperature but not a change in state. So we have three sections here. We're going to have ice in this section. You're going to have water in this middle section, and you're going to have steam in this section right here. In your latent heat categories, you'll see a 32 right here, and you'll see a 32 right here. 32 degrees Fahrenheit is water freezing at sea level. You have a 212 here and a 212 here. That's water boiling at sea level. Now, what's the difference between this one and this one? Really nothing, but as we reach water, as we're coming down here to 32 degrees in the water, we start having ice and water just beginning to freeze. As we get across to this point, we've totally changed state where we have no water left. We have a solid. So you could say solid, liquid, vapor. Same thing here. As water boils, as it first starts to boil, we have steam and water at 212 degrees. As we keep on going, we have a total change of state where it changes it totally into steam. So if you have a pot of water on the stove and you start to boil it, if you let it boil long enough, it will boil all the water and turn the water from a liquid into a steam. You'll have no longer any water in the pot. Alright, so let's look how we're going to do this. So this is going to be for water, so we have specific heat of 0.5 for ice, 1 for water, 0.5 for steam. So we're going to do a calculation, a long calculation. We're going to go all the way up the graph. So if we're going to do that, we're going to have 10 pounds of ice starting at 15 degrees. And we're going to change that to 10 pounds of steam at 215, right up here. So we're going to do a little bit of a sensible heat equation at this point. So the equation would be Q of S equals sensible heat times weight. Weight is a constant. Weight never changes throughout this. Regardless if you've got 10 pounds of ice, it's going to be 10 pounds of steam. It never goes up or down. It stays a constant through this. Sensible heat times the weight times the temperature difference. And this is where people get a little bit confused on what the temperature difference is. So first of all, sensible heat of ice, 0.5. Times the weight. Weight is 10. Times the TD. Well, we're going to have to figure the TD out. It's quite simple here. You get out, you have your calculator, or some of you may want to figure this in your head. Let's check it out right here. So this 32, between 32 degrees and 15, because this is all sensible heat. So what we're going to do is we're going to take 32 minus 15. That's going to give us a temperature difference of 17 degrees between this point and this point right here. So that's what we're going to use over here. We're going to put that in right there, 17. Let's see what that equals up to. And that'll be our sensible heat calculation for that part of it. So let's do here, we're going to do 0.5 times 10 times 17. That's going to give us 85 BTUs of energy. BTU is a British thermal unit. That's how a basic unit of measurement we use to measure how much heat something's giving off or something's actually able to cool down from. Alright, so we've moved from this point, the 15 degrees, to 32. Now we're at a latent heat calculation. Latent heat, it takes 144 BTUs to go across this flat part of latent heat right here to make that change of state from solid ice to water and ice together. So we're going to do a latent heat calculation now. So let's do this. Let's do Q of L. And basically the latent heat calculation is the weight, which is 10, times your latent heat of fusion. So latent heat of fusion. And latent heat of fusion is 144. Let's see what we get there. 10 times 144. So we'll do that. 10 times 144. That gives us 14, we're at 1,440 BTUs. So now we've got to the point where we have come across, we are here. Started here, went to here, now we've come across this whole gap. Now we're going to go through this whole sensible heat thing right here. So we go back into sensible heat again. We're now at water. So we're going to take this up to boiling. So that's going to be sensible heat again. So it's going to take some sensible heat to get this thing up to boiling. So what are we going to do? We're going to do specific heat times the weight times the TD. Specific heat of water is 1. The weight is 10, still 10 pounds regardless of what we're doing. Now we got a TD. So what's the TD going to be here? Well, since we don't have any numbers in there, we've got 212 here and we've got 32 here. So our TD right there is going to be 212 minus 32, which should be 180. Now we need to multiply that up and see what we've got. So we do 1 times 10 times 180. And that's going to give us 1,800 BTUs. So 1,800 BTUs. All right. So now we've taken this thing and we've gone from this point to this point. We've added some more BTUs. Now we've got to go, we're at water and we're boiling. So we've got steam and water together. Now what we've got to do is we've got to take it across this for latent heat because we're going to change the state now. We're going to change totally from liquid and vapor to totally vapor or steam. So we're going to do a latent heat calculation again. Q of L, which is going to be the weight times the latent heat of evaporation or vaporization, depending on which way you're going on the scale. Weight times 970. All right? So weight was 10, so that'll be 10 times 970. Ten times 970. That should give us 97 or 9,700 BTUs. 700 BTUs. Okay, so what we've done here at this point, we've gone across this. Now we're here, we're back into sensible heat, and we're just heating up to this point. So that's going to be a sensible heat equation. So now we're total vapor, and we're just adding heat to the vapor. We're not going to change state again. So Q of S one more time. That's going to be specific heat times the weight times the temperature difference. Specific heat of steam is 0.5. The weight is still going to be 10. And what is our temperature difference? We got 215 minus 212. Which you could do this without a calculator, but I prefer to do it this way. 3. Only a 3-degree difference. So let's get up here and let's do 3. Now let's equal that out and see where we are on our BTUs. So let's do 0.5 times 10 times 3. And that was only 15 BTUs. So it didn't take very much to go from 212 to 215. 15 BTUs. Alright, so what do we need to do now? We need to add all this up. So if we go up here, or go down here should I say, and let's do QT. What's QT? QT is the total, not the gas station. So the total is Q of S plus Q of L plus Q of S plus Q of L plus Q of S. And if we look at that, what was our first one? Our first one was 1440, I'm sorry, plus the latent heat, which was 1800, plus, sorry about that, I messed up, was looking at the wrong thing. Let's start over on that. Let's start, Q of S was only 85 BTUs, the first one. 85 BTUs plus 1,440 plus 1,800 plus 9,700 plus 15. Now let's see what that equals up to, and we'll get our total BTUs of what it took to change 10 pounds of ice at 15 degrees to 10 pounds of steam at 215. So let's add this up and see what we got. All right, so we've got 85 plus 1440 plus 1800 plus 9700 plus 15. So that gives us a grand total of BTUs, which I'll put right out here. This is our total for BTUs, and we're at 13,040 BTUs. Now then, with this being said, we can do just about anything we want here. We could start off here with a temperature and go this way. We could start here and go that way with a temperature, depending if we're trying to take heat away or add heat to. It depends on what you want to do and what the application is calling for. But this is a basic way to do BTUs for water, ice, and steam. Thank you very much. I hope this has helped you out. More videos to follow.